Hello and welcome to the EcoCast. Today we're covering converged, hyperconverged, composable infrastructure, and integrated platforms. You'll hear from Pivot 3, Nutanix, and Scale Computing. Today's event is brought to you by Actual Tech Media, and thank you so much to our audience out there for joining us on today's special EcoCast event. We really value our audience, and we really appreciate you taking time out of your busy schedule to join us on the event. I know from personal experience, the life in IT can be busy and stressful sometimes, so thank you for taking an hour or a couple hours out of your schedule today to learn about hyperconverged infrastructure. I hope you're going to enjoy the event. I am confident you're going to enjoy the event because we've got a lot of great content today. We want this to be an educational event, so we encourage you to use the questions box there. Thank you for all the messages that are coming in already. Feel free to use that questions box during the presentations today because we want to get as many good questions for our presenters as possible. If this is your first time joining an EcoCast, I want to let you know that we at Actual Tech Media created the EcoCast and MegaCast event series to help educate IT professionals about the latest and greatest in enterprise technology to help you do it as quickly and as efficiently as possible. You never have to leave your home office or your office. You don't have to go downtown to the convention center like I used to have to do when I was an IT pro. You can sit back, relax. It even works on a mobile device and, just learn about what's going on in the world of hyperconverged, converged, and composable infrastructure on today's event, but we have many other events that cover other topics like cloud computing, security, storage, and the IT infrastructure as a whole. In fact, one of our biggest events of the year is next week. Before we jump into today's event, we have a little bit of housekeeping here to cover. First off, we have some cool prizes. We always give away cool prizes on our EcoCast and MegaCast events. I'll be talking about the requirements to be eligible for those prize drawings in just a moment. Questions. I see many of you have already figured out how to use the questions and answers box there, so we appreciate that. We'll be answering as many of those comments that are coming in as quickly as we can. But like I said, feel free to use that during the presentations because we want to get as many good questions as possible for the live Q&A sessions that we're doing with each of our presenters on the event today. I also have some poll questions that I'll be answering you here, or I'll be asking you here in just a moment, and I appreciate your participation in those polls. Social, we want this to be a social event. I'll be tweeting about the event over on Twitter. I'll mention the hashtag here in just a moment, but you can actually tweet directly from the console using the Twitter icon on the bottom of the screen. If you, the first time you tweet, it will prompt you for your Twitter username and password. That's kept just between you and Twitter. And then from there, the hashtag will be automatically appended. And then finally, resources. We have some handouts. If you click on the handouts tab in your console there, you can download the handouts that were selected by today's presenters for further information. Now, the prizes on today's event are 3 Amazon $500 gift cards. We'll be announcing the prize winners after each of today's 3 presentations. So after every presentation, there will be a prize. If you're watching this event on demand, I'm sorry, the prize drawings have already occurred. You must be present on the live event to be eligible. There are some other prize requirements, and you can find those if you go to the Handouts tab and scroll down to Prize Terms and Conditions. They're also on our website, events.actualtechmedia.com. All prize winners must submit an IRS Form W-9 to Actual Tech Media. Now, through the MegaCast and EcoCast event series, we have had very generous attendees who have chosen to donate their prize values to charity. If you'd like to do that, if you win a prize, we would love to help you do that. So thank you in advance. These are the charities that we have chosen to support over the years. The hashtag for today's event over on Twitter is HCI EcoCast. You can follow Actual Tech Media for the latest and greatest in enterprise tech. We are at Actual Tech Media, and I am David M. Davis over on Twitter. Feel free to follow me as well, and I will follow you back. Now, you can subscribe to Actual Tech Media channels on YouTube, on Facebook, and our 10 on Tech podcast over in the iTunes store. If you go to the top right-hand side of your console, you'll see icons there for LinkedIn, Twitter, and YouTube. Just click on those. Those are hyperlinks, and they'll take you to our homepages on those respective websites, and you can subscribe or follow there. We post a lot of great content on LinkedIn and YouTube especially. Now, before I introduce today's first presenter and we do some poll questions, I want to do just a little bit of level setting here to kind of set the stage for today's topic. I was an IT manager and system administrator for many years. Back then, we didn't have many hyperconvergence and composable type solutions like we have today, but the challenges, I think, are really the same, but even more so. I mean, every IT shop out there, every company, large or small, is struggling for ways to find ways to achieve greater efficiency. Everybody needs greater efficiency. We need greater agility in IT. We need to keep up with the speed of the business because the expectations today, I believe, are higher than ever before. Everyone's on their mobile devices. They're using web-based internet applications that seem to be up 24/7, and now they expect IT, their internal IT applications, to be up 24/7 by 365. They expect agility. They expect to be able to point and click and add a new application or scale up, to a much higher number of users in just a few clicks of a mouse. They expect that kind of agility and scalability. And they also expect more of IT at the same time. They expect us in IT to be able to do more with less staff. They think that IT should just be easy, and we in IT know that it's not always as easy as it might seem. They also expect more out of the same IT spend or less spend. So we get the same budget in many cases every year or sometimes reduced budgets, but yet they expect us to do more and more. And to me, the solution is better and smarter software. Through innovative hardware and software, we can become more efficient in IT. And we need to be able to achieve that agility and scalability of staff and cost savings in the data center. And to me, convergence and hyperconvergence and composable integrated solutions help to really make this possible. So if you aren't familiar with some of these terms, just kind of a quick level setting on the definitions. I mean, converged infrastructure is when you group multiple IT components into a single optimized computing package. So I might buy a rack or a package of servers, and they have storage and perhaps networking and hypervisor all integrated together. So with converged infrastructures, the components might be servers, storage, networking, and a single infrastructure management, a software layer, and hopefully with automation and orchestration. Hyperconverged infrastructure, on the other hand, is typically more software-centric, architecture that tightly integrates storage, networking, and virtualization, sometimes on commodity hardware, sometimes on hardware provided by the manufacturer, and typically with a single point of support and management. Composable infrastructure, on the other hand, is more of a framework where a physical compute, storage, and network is treated as a fabric of resources and services that you can logically pool and provision on demand. So you don't have to physically configure hardware to support a specific software application. One day, this server or cluster of servers can be a Windows cluster. The next day, you make a vSphere cluster. The next day, you make it a Linux cluster. That type of thing is possible with composable infrastructure. And so my take on these different solutions is that they help to make your IT infrastructure more efficient. They help to save you time and money, and your company time and money. They help to make your life easier as an IT professional, help you to do your job better, and hopefully to make you more of a hero for the IT organization and for the company, help you to do things that you should be doing to enable new innovative technology in the company instead of just managing the LUNs on the storage array and provisioning RAID groups. I mean, that doesn't help the company to be more competitive or more agile. That's just more of a maintenance thing. So hyperconverged infrastructure hopefully will make your life easier. When it comes to selecting these and analyzing the different solutions, every solution has pros and cons. So try to identify that as you walk through these presentations. select the solution that's the best fit for you and your company, and take the time to fully test before you buy. Do a POC, a proof of concept. Just about every vendor out there is going to be glad to do some kind of POC with you, to work with you and show you the value of their technology before you write the check or whatever the purchase model might be. So I'm thankful for today's event. It helps IT professionals such as ourselves to learn more about hyperconverged and composable infrastructures. Today you'll hear from Pivot 3, Nutanix, and Scale Computing. I've seen the presentations. They've got some great stuff lined up for us today. Now, before I introduce our first presenter, I've got, 3 quick poll questions for you here, and I'll share the results of these polls with you. The first one is, what's your industry vertical? And you may need to scroll down on the right-hand side of the slide window there to see all the different verticals. And this is actually a good time to take your mouse and mouse over the corner of that slides window. It'll turn into an arrow, and then click, and you can drag it out. You can make that slides window as big as your web browser or your screen can handle. You can even maximize the slides window. However, I don't always recommend you do that because it kind of covers up the questions and answers box there. So it's good to kind of have both the questions and answers and the slides window share the screen if possible, with more real estate given to the slides window, because we have some cool videos, we have some architectural diagrams, maybe some live demos, so make sure you make that slides window as large as possible. All right, looks like most everyone has responded to this poll. Let me share the results with you. And if we scroll down, looks like 26% are from technology companies, followed by 12% healthcare, 7% higher education, 7% manufacturing, and a good representation of all different sorts of other companies here. Telecom, 6%, K-12, local government, state and federal, that's a combined 11%. So real good representation on the event today. Thank you, everyone who responded to that poll. The next poll question here is, how many people work at your company? And again, I'll share the results of this one with you. It should be a pretty easy question to answer. And it looks like 23% are from 100 to 500 employee companies, 15% from 10,000 plus, so very large companies. Roughly 21% are between 1,000 and 5,000, and 12% are at small companies. So thank you, everyone who responded to that one. And then last poll question before I introduce our first presenter, and that is, what's your time frame for updating your existing or selecting new infrastructure solutions? If you're on this event, it's probably because you might not be happy with the storage or the compute or the infrastructure you have in the data center, and maybe you're looking for some new solutions. So just curious what your time frame might be. Is that an immediate need, 0 to 6 months, 6 to 12, 12 to 24? As soon as you answer this poll, we will get started. All right, thank you everyone who responded to that poll question. We do appreciate that. And now it's my pleasure to introduce our first presenter on today's EcoCast. That is Mr. George Wagner, Senior Product Marketing Manager at Pivot 3. George, are you with us?
I am. Can you hear me?
I can, yeah. Thanks for being on. Take it away.
Awesome. Thanks a lot, David. Thank you everyone for having me on today. My name is George Wagner. As David said, so I'm a Senior Product Marketing Manager here at Pivot 3. I've been with the company here in some way or another for the last probably 8 years now. And I'm really excited to go through and introduce you to our hyperconverged infrastructure solutions and really help you understand how they can really solve a lot of relevant challenges that many of you are facing today. All right, so before we get going, and by the way, I'm going to give also a live demo, so fingers crossed everything works out, but I hope to give you a live demo at the end of this as well. So we'll get through these slides and do some talking, and we'll do some Q&A.
Awesome.
So
yep.
There we go. Okay, go ahead.
Yeah, we do have a poll question. I do want to point out to everyone to respond to this poll question on the screen. Just says, what are your use cases for HCI today, or what are you considering use cases for HCI in the future? So I know this will help George shape his presentation, perhaps, and we appreciate everyone answering that. And I'm really looking forward to the live demo, George.
Excellent. Yes. Yeah, I think it'll be great. Oh, these are great results. This is kind of what we're seeing a lot as we're talking to customers as well. So I'll tell you, I'm seeing it beginning to shift from so much. It used to be a lot about targeted applications like database only or VDI only. As you can see here, number 3 on the list is consolidation. We're starting to see that increasingly become kind of a go-to solution for HCI. So no, this is very encouraging, and like I say, it really speaks to kind of what we're seeing when we're talking to folks, and I think it really plays well into what we're able to do here at Pivot 3, especially around providing consistent, predictable performance and experiences for the end users around consolidation, database, VDI, as well as kind of those more remote cases for backup and data protection. So that's really great to see. Thank you. And for those of you who aren't familiar with Pivot 3, so Pivot 3, we're considered a leader in the hyperconverged space. So we've been around since early 2000s, starting off in software-defined storage and moving into hyperconverged infrastructure once we really saw the ability to capture some of that excess CPU on those growing Intel processors and virtualize them and create really a hyperconverged infrastructure that not only supports your traditional data center applications, and this kind of is why I'm bringing this up, but it also I saw some of the polling question that David asked before I started, which was kind of the verticals, the areas in which you all work in. And I saw a lot of healthcare, SLED, and et cetera. So we also provide hyperconverged infrastructure for video surveillance, analytics, virtual security operations centers and things like that. So it's a lot of what I'm talking about today, which is focused on data center, can also be applied. Those benefits can be applied into those areas as well. As you can see, we've got over 3,000 customers and 20,000 plus systems deployed across 65 countries. We're headquartered in Houston. I'm actually in unusually snowy Colorado this morning. And with that, let's kind of get into discussion, really talking about kind of the IT challenges, the way that I see them. So I am a former IT manager. I did some physical security with that as well. And I have the opportunity to be put in front of many customers. I go on the road quite a bit and talk to potential customers, existing customers, and talk to them about a lot of the challenges they're facing. And a lot of it has to do now with the fact that there's a need for instant response around applications, right? We've kind of created this behavior with cell phone technology, 4G, all these different technologies that are really increasing the expectations of the end users. So they really want those SLAs met right now on a variety of applications. And from the admin standpoint, they're doing more with less. All right, budget-wise, staff-wise, they need to be able to do more with less, and that means really managing that infrastructure much more efficiently. Controlling costs, keeping up with those expectations, as I mentioned, and of course ensuring data security and compliance in this day and age is becoming more and more difficult as there's always exposure, risk exposure out there. If you're not encrypting and keeping things under wraps and protected. So those are a lot of the challenges that I'm seeing right now. And if you look at the types of infrastructure, solutions out there that are available, and David went through this, but there are really three main types at the moment, right? You have your traditional three-tier, infrastructure, which is basically, I can tell you from being a guy who worked in this industry and having managed this stuff for a while, is you can pretty much configure that to do anything, right? If you have the right budget and you have the right folks on board, you can manage it. But you need to have that budget. You need to also understand that it could be harder to scale. You end up with silos of equipment, silos of management, et cetera. So, disparate management, disparate components. Converged infrastructure is still around, and it came out earlier than hyperconverged, but main benefit there was to have a single pane of glass, as well as your disparate components, but all of it managed centrally, which really enabled the more efficiencies around the management side. But really, you're still left with, from a capex perspective, and also racks, cooling. You had this massive amount of hardware still. And that's where hyperconverged infrastructure really stepped in by consolidating the servers, storage, and storage networking onto a single manageable solution that maybe even a single person can manage. And that's really the idea behind it. Increase agility, operational efficiency. And when hyperconverged infrastructure came out, it was really designed around it was really a point solution, right? So it was for VDI, or it was for data center, a line of business application, et cetera. But one thing that it really wasn't designed for initially, at least, was for consolidation, running multiple workloads, and that's really an area that we sought to address when designing our own infrastructure. So with Pivot 3, what we've done is we've really designed a system around three core pillars, right? One of those being performance, right? We understand that performance is important, but more important than just delivering performance is delivering that low latency performance to the applications that matter to our customers. So we do that. You'll see here in the next couple of slides around, we've integrated NVMe, PCIe flash directly into the architecture. And it's right not only in the architecture, it's in the I/O path. So each I/O that goes in and out of the system hits NVMe flash as an accelerated. But it's not just about having performance; it's about ensuring that it gets to the right applications. So we have simple policy-based performance management, security management that ensures that performance gets to the right application at the right time. And then finally, of course, it's about efficiency. So data protection, obviously important. We do have erasure coding built into the system, which is on all the time. Provides a more efficient way to deliver real-time data protection from drives and nodes going offline. So and also scalability. So these are all things I'll touch on, but these are really kind of, as I mentioned, the core tenets of Pivot 3's hyperconverged infrastructure. And as I mentioned, from an architecture standpoint, we designed it what we call a multi-tier architecture. So it's all around that PCIe NVMe flash. So NVMe flash in and of itself is fantastic because you're no longer treating SSD or NVDIMMs like disk drives, right? By issuing SCSI commands at them. NVMe has its own commands. There's like 7 of them versus hundreds of SCSI commands. You don't want to tell a solid state device to do a seek when you don't have to, right? So it's much more efficient. The fact that we're using PCIe flash means we're plugging it straight into the PCIe slot and getting up to 16 lanes of performance out of there versus maybe 4 to 8 on a traditional NVMe drive. So it provides a lot more performance than in traditional SSDs or even conventional NVMe devices. So much more faster response times. And that can be easily scaled as well. We do wide striping, so we essentially cluster the systems under the covers. There's VMware is doing the server virtualization. Pivot 3 is doing the storage virtualization. Both of us are highly available. All the data is striped across all the drives to maximize not only the drive performance, but also the throughput, and it scales online, as you'll see here in just a moment. But the idea is just to increase the ROI by maximizing resource utilization across the entire cluster. From a management perspective, performance management perspective, I mentioned a few minutes ago that it's not enough just to have high performance if it's not getting to the right applications. I think many of you would agree with me that there are such things as rogue VMs, applications that, and even physical systems where you have applications that don't really warrant the need for high performance, low latency latency but because they're on a shared storage system and there's no way to regulate where that performance goes, it just gets consumed by any application, right? So what we've done is we've designed the system around quality of service and service levels to really provide simple performance management. So for us, we don't believe that our customers need to be performance experts in order to manage performance. We have 5 simple policies that manage performance in terms of minimum IOPS, minimum throughput, and maximum latency or maximum response time. And when a volume is provisioned, and I'll show this to you in the demo, when a volume is provisioned, you simply assign a policy to it, and when you assign a policy to it, it is it's set up to ensure that those minimum performance levels will always be met. And if you need to, you can set it up to change policies anytime during the day if you need to. So in the case of power users, so in the case of VDI, I saw a lot of respondents in there talk about VDI as being kind of one of the use cases that they're using today or considering using in the future. Let's say you have a boot storm in the morning and you have VMs that don't need the highest desktops that don't need the highest level of performance during the day. However, from say 7 a.m. to 8 a.m., it's a barrage of logins that are occurring, and there's a ton of latency involved. People are yelling at you, etc. Right? We all know that is. This with Pivot 3, you can schedule the policy change from policy 3, which is what we call kind of a business critical level 2 up to business critical level 1. Move it up for that hour, then move it back down. Right? So you can change it real time. It really makes a lot of difference in response. That's not only for VDI, right? That could be for if you're running end-of-month reports in certain databases, right? You can be pretty creative with it. We have a lot of customers that are pretty creative in how they're doing this. From SLA perspective, right? What happens when you lose a drive or you lose a node or anything happens where traditionally it degrades all workloads? We have what are called service levels that step in and ensure that performance is guaranteed to what we call mission-critical workloads. So as you can see here, we have these service levels that are assigned to every single performance policy. There's mission-critical because this workload, the order database, is critical to my business staying online. We want to ensure that it gets the performance resources it needs. And in order to do that, if we have to take performance away from one of our lower level volumes, such as this policy 5 that's assigned to the dev database, I'll do that. We can give it the performance it needs as long as it does not impact the higher level policy. So it's pretty intuitive, very simple to manage, obviously, and we're probably in our 5th or 6th generation of our quality of service. It's extremely advanced, and I would say as far as what differentiates us in the market and where customers tend to choose Pivot 3, especially in the data center, those 3 things I just talked about were huge. However, when it comes to scalability, you want to be able to scale online only what you need, and we can do that, right? You can scale both compute and storage. You can scale storage only. You can scale compute only. You can add GPU, and as you're adding additional nodes and rebuilds are taking place, not rebuilds, but restriping, for example, because we are clustering, the data has to be moved around. We still enforce the performance policies on the volumes. Therefore, you're not going to completely beat up your mission critical volumes. We guarantee that performance meets those. And then from a maximizing your IT ROI perspective, you can connect the Pivot 3 system into any if you have an existing storage investment that you want to keep using, by all means keep using it. Right? You can mount mount VMs from the Pivot 3 hyperconverged infrastructure directly to external storage. You can also take external VMs and mount them up to Pivot 3 storage, because this is a nice fuzzy SAN at the end of the day. You can mount up volumes, and you can have QoS managed volumes that are very low latency with the performance that we were able to deliver. For those VMs, those applications that are external to the hyperconverged system. So it's very flexible in that respect. you hear kind of in action what we've done. This is an example of one of our customers in the healthcare industry. What they had as a challenge was they needed to refresh their virtual environment, and they had several applications that they wanted to be able to consolidate onto this. And they were very concerned because they were in the life sciences that they needed to ensure that those databases were getting the performance they require, but also that their remote users, their virtual desktops, were also receiving their expected performance level. So what they decided to do was consolidate on Pivot 3's HCI, and for server virtualization and VDI, they used 5 hyperconverged nodes, and they saw a significant reduction in their latency that they were very excited about. So around VDI, as well as consistent sub-millisecond latency to their mission-critical volumes, which are their MySQL databases, and then 20% increase in usable capacity. So around the erasure coding, which is something I don't have a whole lot of time to go into, but the idea is that we can provide, rather than doing traditional replication between nodes for protection, we can provide much more efficient data protection by employing these erasure coding algorithms that allow us to provide anywhere from 57% usable capacity with 3 nodes all the way up to 86% usable capacity with 16 nodes. So it increases over time. That's something they're very excited about. But really, before I get into the demo, kind of a quick demo. Bottom line is, we really designed the system to address a lot of the modern workload needs around both traditional data center, as well as I mentioned, and you can definitely reach out to us. We can provide you more information, but also around surveillance and security, so physical security as well. So a lot of the efficiencies and benefits that I was talking about really span both areas, and we're starting to see these two distinct markets or technologies merge together as video data is increasing at a high clip with IoT, et cetera. So definitely something to consider as well. So with that, I'm going to share my screen.
There we go. I see your web browser with the console. There we go. I see Pivot 3.
Perfect. All right.
I like
awesome.
that interface. Yeah.
Woo. Okay. Yes. I was keeping me up at night. Okay. So this is our UI. Essentially, it goes inside of vCenter, so it's a plugin for vCenter. It's using HTML5. There's a couple of things I wanted to show you in here. Obviously, you can manage everything through a single pane of glass. I have a couple of systems in here. This Acuity storage is our data center storage, and we also have a cloud storage piece in here, as well as SSD and SATA-based systems. Before I go in and kind of give you a demo of the QoS, this is a screen that I can show you that's giving us summary information around we call it a VPG, but essentially it's a cluster of systems. But as you can see, here's the NVMe PCIe flash in the system. It's telling me it's healthy. I'm running a synthetic workload on here, right? So we're able to get obviously insane numbers, but we can go higher than this. This is the way we've sized the systems is that if you lose a node that has PCIe flash in it, you'll still be able to maintain the performance to deliver to the mission critical workloads. So, but you can look at IOPS throughput, all that's in here, and that's for the entire system. And let's see here, something else I wanted to show you. Let's see here, data services. So these are the policies I was talking about. So policies 1 through 5. There's the mission critical associations with them. It tells us how many volumes are associated with those policies. In fact, when you create a volume in Pivot 3, when you provision, you have to assign it to a policy. So it's real simple to do. But there are the minimum targets. So since we're using minimum performance levels, it means that you can have as much performance as you need, and we'll guarantee that you'll meet at least this minimum performance level. That's kind of the idea behind it. And then we use what's called a read warmer, which intelligently moves data into the NVMe, what we call read cache. The portion of NVMe is used for read cache as well as writes. So we can move those in there depending on how many hits occur, read requests occur at those volumes. So you can see we have it set up to where, if you have 16 hits on policy 3, it'll move in, but if it's 1 hit on policy 1, it'll move in. So it's pretty intelligent in that respect. But the one thing I want to show you before I pass it back is a demonstration of the quality of service. So right here in the performance monitor, and I'll shrink this just a tad. There we go. I'm showing a couple of volumes that are running on one of my clusters, and one of them is assigned policy 1, which is this guy right here. So he's maintaining around 1.5 millisecond latency, give or take. And then this one just below it is at 6 millisecond latency, right? So it's using policy 5. What I'm going to do is I'm going to switch these two, and I want to just give you an idea for how fast that this change can take place. So let me go back into that, and we'll open this guy up. We'll change him from 1 to 5. We'll apply it. Just take a second here. All right. This one, change him from 5 to 1. All right. So now if I go back into this toolbox, there you go. So you're going to see that. Here we go. It's starting to happen now. So this volume which was originally a policy 1 is now a policy 5. So it's seeing a higher level of latency, higher response time, and we switched this guy down to mission critical, which means he instantly dropped down to very low latency. So with that, I want to be mindful of the time, and I'll kind of go pass it back to David if he wants to ask any, or we go to the Q&A part.
Yeah, absolutely. Yeah, great demo, George. Love to see the UI there. I like the HTML5 plugin for the vSphere, web client. Very cool stuff. So let's see. We do have some questions that came in from the audience. Chris is asking about erasure coding. Do you have any other options like RF2 or RF3?
So yeah, those are erasure code levels that are names that are given by a vendor. We have what's called EC1, 5, 3, which protect from one drive. The EC1 is a drive in a node, which I would never use, but some people want to use it for scratch volumes. But the most common one in the version, the type that's on all of our data center nodes, is what we call EC3. So by default, if you provision a volume in our data center edition systems, it means that it'll survive up to 3 drive failures across the cluster, or 1 node and 1 drive across the cluster. So it'll be that's how it protects. But yeah, just every vendor has different names for it. That's just what we call ours.
Got it. Okay. Good answer. I want to point out to the audience, I just popped up a poll question in the slides window there. It says, what additional information would you like about the Pivot 3 solution? I'll just leave that up while we do some more Q&A. Chris is asking, does it run vSphere only, or are there any other hypervisors that it supports right now?
Yeah, great question. So initially we actually started off with KVM, but we decided for simplicity reasons, at least at that time, to switch it over to vSphere. So we run vSphere right now. We've explored using Hyper-V, decided that wasn't the best route for us. But yeah, so for the moment, it's just vSphere.
Okay, got it. Phil is asking about deduplication. Is that possible?
Mm-hmm. Yeah, so we use a data reduction technology that's I'll just tell you, it's a pattern matching. So we have a list of common patterns that occur in data. So ones, zeros, there's a couple of other, all ones, all zeros, ones and zeros, and there's one more which it escapes me right now. But we look for those and we can strip them out as they're being the write request is occurring and update the metadata table. And then as data is being read, we can go ahead and generate that out of RAM. So it's very efficient. Depends on the type of data you're using, but we see a lot of benefit around VDI and especially around VDI.
Nice, nice. Another question here: does Pivot 3 sell appliances, hardware appliances, and software, or just software?
Great question. Yeah, so we do sell the whole shebang. So we do appliances that are pre-integrated. We have customers who believe they can acquire the hardware configurations, the off-the-shelf hardware from Dell or Lenovo at a better price. We're definitely happy to work with them on a software only if they want to do that as well. But we do either.
Okay, nice. Another question: are storage nodes part of the HCI cluster, or are they a separate cluster?
Yeah, no, it's a good question. I didn't really get into that. So, yeah, if you decide that you need more storage, then you really don't need the compute portion, but you need more storage in your cluster, you simply add a storage node. The storage node can be added in, and it is part of the storage cluster. Obviously, there is compute in the node because it needs to be able to run our operating system, but it does allow you to not have to purchase multiple cores, lowers the RAM requirements, and of course you don't have to run ESX on there, so it reduces that cost as well.
Okay, nice. Chris is asking, do you support snapshots, and can I schedule snapshots?
Yes, absolutely. Yeah, another thing I didn't have a whole lot of time to go through, but yes, we do have some data protection around snapshots, thin provisioning, replication, volume encryption, encrypted volumes being replicated. We can even replicate that to a cloud version of our systems that runs in AWS. So if you want some data protection against that, you didn't have a second site, you can replicate that up to AWS as well.
Oh, okay, nice. Well, George, I think that's all the time we have for our live Q&A session here. There are a few more questions in the queue that maybe you can respond to.
Yeah,
it's really great having you on the event today. A great demo. We got a lot of good feedback on the great demo. So thank you for being on.
It's always fun. Thanks for having me. Appreciate it.
For more information on Pivot 3, click on the Handouts tab, and you can click right there where it says Pivot 3, and that will take you to the Pivot 3 Resource Center. And there are just tons of resources in there, white papers, case studies, videos, webinars, all sorts of stuff if you'd like to learn more about Pivot 3. And with that, it's time for our first gift card award. That is an Amazon $500 gift card, and it's going out to Joe Price of Georgia. Congratulations, Joe Price of Georgia. We've got 2 more to give away, so make sure you stay tuned for those prize drawings. And with that, I'm excited to introduce Krishnan, who is a Director of Product Marketing at Nutanix, for our next presentation. Take it away, Krish.
Thank you for joining this webcast. So today I'd like to talk to you about why you need to take the journey to the enterprise cloud and how you can accomplish that journey. So first, I want to highlight what's top of mind for CIOs and CEOs today. There's a lot of conversation around how CEOs are paving the way for digital innovation to augment customer experiences, use digital avenues to create new opportunities and such, as well as expanding their organization's addressable markets. Now, all of this begins to fall back to the technology organization that's looked upon to unlock these opportunities, digitize processes, create new avenues that customers can interact with companies, be it through web tools or smartphone applications and such. So all of this puts a lot of demand and pressure on IT organizations. Now, given these tall demands, it's a lot easier said than done, right? Because we are still operating infrastructure like we have over the last couple of decades. We've got these various silos within the organization that require us to work with multiple vendors to acquire infrastructure, software that sits upon the infrastructure. And once we've done that, painstakingly put it together and integrate it such that it works seamlessly when in production, and when deployed, manage this infrastructure across specialist teams, namely for server, virtualization, networking, and storage and such. And when problems happen, come together in a room to troubleshoot what the problem is, and half the time devolve into blaming other teams for being the root cause for that particular problem. None of these scenarios are enjoyable, right? And it only gets worse when you need to roll out upgrades to various elements of the infrastructure stack, be it the BIOS or the virtualization layer, whatnot, right? That might disrupt the performance of the entire stack and have incompatibilities with other layers of the stack. And before you know it, 3 to 5 years from now, it's time to do it all over again. It is no surprise that this operating model forces us as members of the infrastructure and operations teams to focus on the speeds and feeds. We focus over 80% of our time just upon the infrastructure when our stakeholders within the business or outside our customers and partners really care only about the 20%, the applications that run upon the infrastructure and that are consumed by them to get their jobs done or consume the services that the company is providing. They have no appreciation for what's under the water level. But we as members of the IT infrastructure and operations teams understand that for those applications to perform 24/7 seamlessly every single second of the day for our customers and for our business partners, you need a solid bedrock that's built upon the infrastructure. So quite often, what we do, the role we play is that of an unsung hero, right? So, and this has been apparent based upon a survey we just conducted across a global audience of IT leaders when asked whether application developers collaborated with them when they needed IT infrastructure. 57% of them said that application developers consistently circumvent IT because IT is perceived as an inhibitor to innovation as opposed to one that fosters innovation. Now, we as members of the IT infrastructure and operations teams are smart, right? We understand that what forces us to stay in the speeds and feeds is the infrastructure itself. So one very viable option is make infrastructure someone else's problem, right? Enter the public cloud. So by doing so, you've basically outsourced infrastructure to a third-party organization, namely the public cloud vendor, and you're able to immediately offer those benefits to your stakeholders, right? They're able to deploy applications. Now there's this perception of less management. You get to pay only by use, so you don't have to commit budgets for a 3 to 5 year cycle. And finally, the infrastructure just keeps getting better and better with the continuous updates that are being pushed and deployed by the cloud vendor. But what we found is applications are beginning to return on premises within the data centers. Based on a survey we've conducted, we found that respondents said that they were 35% consistently over budget with their public cloud spending. And 80% of those respondents are moving over 50% of their applications back on premises. And this trend is not slowing down. It was 81% last year, and it's trending at 85% in 2019. So what's truly needed is this harmonious balance between public cloud and private cloud, where you've got workloads and initiatives that are best suited for public cloud that are targeted towards your public cloud deployments. And for those more predictable enterprise-grade, business-critical applications that require performance control, the best place to land those applications is in the private cloud environment. And that is where we help customers get those public cloud benefits within the constructs of their private data centers. And we do that by delivering software-driven hyperconverged infrastructure that can be deployed upon infrastructure platforms of our customers' choices, and also enable customers to choose the virtualization layer that they would prefer based upon current skill sets or the natures of the workloads that are being run upon them. So this enables our customers to not just harness the benefits of public cloud within their private data centers, but also choose how they create their cloud experiences within their own data centers. So that is the dual benefit of choosing to use software-defined hyperconverged infrastructure to do that. And you'll find that, based upon the survey that I referred to previously, IT leaders across the world subscribe to this point of view. They want to land about 36% of their workloads on hybrid cloud, a significant number in private cloud, and about a quarter of those workloads within the public cloud. Now, this, while it might seem like a very harmonious solution, it causes other challenges where you've created silos between your environments where they previously existed between layers of the infrastructure. The applications and data are not portable across public, private, and distributed edges. There is different management methodologies across private, public, and distributed edge. So typically, you would find that you have the chief Amazon officer or the chief Azure officer, the CIO that continues to control the private cloud, and this emerging title that we've seen at some of the larger organizations called the chief digital officer that tends to manage more of these IoT and forward-thinking initiatives that address these distributed edge use cases. What's truly needed is to create one fabric of infrastructure that spans across these disparate environments, along with a shared pool of data that can be leveraged irrespective of where the applications need to land or who is building or delivering these applications, and upon which a shared set of services are constantly available to the innovators in your organization so they can very quickly deliver results with their innovations, right? So this is where IT has an opportunity to change the perception of being inhibitors to innovation to one that fosters innovation by really delivering that platform that fosters innovation to the multiple stakeholders within the organization, irrespective of whether they sit at HQ or are building edge applications or IoT applications in Timbuktu, for example, right? So this is where Nutanix has set its vision, to be able to deliver that enterprise cloud platform that is easy to manage and control from one single user interface across these disparate environments, so as to enable IT to deliver against business requirements as opposed to manage the speeds and feeds and the underlying complexity of these infrastructure deployments. So how did we go about doing that? First, the public cloud has done a lot of this at scale, right? So to begin, what we did is we took a good look at what best practices were put in place to enable public cloud architectures, right? And those included by making sure that there were no single points of failure, that it ran on off-the-shelf hardware, that it incorporated self-healing systems that enable the infrastructure to run at scale without an army of IT specialists to manage it, and pervasively adopt machine learning automation capabilities that were able to observe infrastructure performance and take action when possible to ensure that the environment was running without disruption and the applications are running at top performance. And to do this, when you do this, well, you get all those public cloud benefits, the rapid time to market, the ability to pay as you grow, so you can start really small and scale out as your needs and your demands grow, and to be able to capitalize upon one-click operations that enable you to do complex operations with a single click. So what does this look like when you look under the covers? So what we've effectively done with hyperconverged infrastructure delivered by Nutanix is take what you see on the left, the traditional architectures where you've got the compute farms, the storage networks that connect up to the various SANs through the storage controller, the virtualization layer that sits on top of that, finally allowing the applications to be run upon this infrastructure. So we've taken the complexity you see on the left and reduced it to a turnkey software-defined computing platform, right, which is delivered by Nutanix AOS. And what makes this really unique is that you can start small and scale out as your needs grow, non-disruptively. And it also allows you to use the virtualization layer that you would prefer to use on top of Nutanix, or enables you to use the built-in virtualization capabilities, namely AHV, that is delivered by Nutanix. When you go to public cloud, the last question you ask is what the virtualization layer is, and we believe that this should be the experience that you enjoy when you are using a hyperconverged infrastructure-powered private cloud within your own data centers. And what makes this increasingly attractive is that it works with your existing rack configuration and your top of rack switches as well. Now, how did we get this done? So looking under the covers, right, here is what a traditional virtualized environment looks like. You've got your server farms, your hypervisors, your VMs that run on top of it, storage networks in the SANs. So with converging storage solutions, with HCI, what we've done is we've eliminated the need for those SANs and added storage into the nodes that sit within the compute farms, right? And you can choose a variety of storage technologies, be it flash, NVMe, or spinning disks, that sit with all these nodes. And once that's done, you virtualize the storage controllers. So in effect, what you've got is one distributed storage pool that spans across the nodes within your cluster that enables you to start small and scale out without limits. Performance only gets better as you scale out. And you can begin to imbibe some of those public cloud practices, which enables you to convert capital expenses to operating expenses by starting based on exactly what you need and using demand and new application workloads as reasons to scale out that environment over time. Secondly, it's got a lot of storage smarts built into the software that enable you to keep data local to those workloads. For example, if you've got an application running on node 1, the data associated with that application is kept in node 1. So what you've done is you've eliminated hops that would otherwise have existed on the storage network, and as a result, you enjoy increased IOPS. Finally, there is no notion of refresh in this mode of operation. You can mix different node types from different hardware generations within a single cluster, and that enables you to continue to add new technologies while still getting the benefits of older technologies that run within this hyperconverged infrastructure-based cluster. Now, the storage capabilities are advanced and meet all of those requirements that enterprises have, right from being able to very smartly tier data between various temperatures of storage that you might have in the node. If data is more hotly accessed, it's kept in the hot tier, namely flash, and if it finds that it is accessed less frequently, it will move the data to spinning disks if you have a hybrid storage environment. Secondly, it has native compression capabilities, deduplication capabilities to give you greater economies on how you use your storage. And finally, it's got RF2, RF3, and erasure coding built into the software that enable you to make sure that you are protected from any data losses. So every time there is data written to a specific node, it keeps copies of that in other nodes as well. So if that node were to go down, or if that disk gets corrupt, those blocks are recreated and data is preserved. It also has you protected from a DER perspective, from a disaster recovery specifically, that's perspective, right, where it has native capabilities to help you synchronize across environments. So in the case of a failure, you can seamlessly fail over to a secondary site and fail back when your primary site is back up and running. It also has advanced security capabilities by being able to automatically check for security compliances and bring it back to the state, bring it back to compliance as well, right? So, it augments that further by being able to ensure that data at rest is encrypted. So it has support for both software self-encrypting drives, or enables you to use software-defined encryption capabilities along with local key management. Now, in effect, you've been able to, with this, it's not just about consolidating infrastructure, but it's about consolidating operations as well. So with Nutanix hyperconverged infrastructure, what you're able to do is exactly that. You've got one single pane of glass that's delivered through Prism that enables you to very quickly acquire new infrastructure as and when you need it, as your environments need to grow, and add them to your clusters, which is then auto-discovered, and the resources automatically added to the pool, right, both for compute and storage. And when it comes to managing your infrastructure, it gives you end-to-end visibility across your infrastructure, right from the compute, storage, and the virtualization layers, along with the ability to detect anomalies when performance is being impacted. Or if you're looking to optimize your environment by eliminating idle VMs or often VMs, or managing QoS for VMs, bully VMs, or under-provisioned VMs. And fourthly, and almost as importantly, is that it enables you to do one-click upgrades across the infrastructure stack. Those painful processes that go into studying compatibility matrices and ensuring that you've created a right dependency map for upgrades across the infrastructure stack, whether it's at the firmware level or the hypervisor level, you're able to reduce all that into a one-click process right from within Prism. With Prism, you can orchestrate upgrades right from the BIOS up to the hypervisor and any other Nutanix software you have in place with one click. And Nutanix understands the dependencies across all these elements in the infrastructure stack and is able to orchestrate the right order of upgrades for you. Then finally, we spoke about scale, where you can continue to understand the runway of your environment based upon past behavior. So you will be able to get real-time visibility into when you will run out of resources and what you need to do and in terms of acquiring new infrastructure and software to be able to plan for growth or to add additional workloads to your environment. Now, this is something we've all been proud of, and our customers enjoy the simplicity and the ease of use that hyperconverged infrastructure has been able to deliver within their environments. Here are examples of customers. The first one doing an upgrade from a helicopter using a smartphone, and the second one is another customer doing an update from his Tesla, and the third one is just a Nutanix fan who has a lot of Nutanix swag, right? So I thought it was a fun picture to add in there. So Nutanix has a lot of versatility, right? So it's not a point solution for any specific workload. What it enables you to do is to really achieve that enterprise cloud platform that you need to run a variety of workloads, address a variety of use cases within your organization, right from being able to run those enterprise applications or deploy VDI environments built upon Citrix or VMware, or consolidate infrastructure management and operations across multiple sites, including data centers and remote and branch offices, to be able to deliver collaboration and unified communication solutions for your workforce, to address the needs of developers by giving them cloud-native stacks or developer clouds that they can innovate upon and eventually delivered into production upon a Nutanix-powered enterprise cloud environment, to be able to run big data workloads, to exploit large, massive, vast amounts of data and gain intelligence to make better business decisions, and to rely upon the platform to run those mission-critical workloads built upon SAP and Oracle, which have to be resilient and performant 24/7 to keep the business running. And, of course, to be able to do all this while you have the power to choose which hardware platforms you want to run the hyperconverged infrastructure software upon, and which virtualization layer you want to put into place based upon skills that you have and the applications that you want to run within your environment. Nutanix has been recognized as the undisputed leader in this area, specifically for hyperconverged infrastructure, by leading analyst firms, namely Gartner, Forrester, and as the leader from a market share perspective by IDC. We also did a TCO study. We commissioned a study with IDC to understand what the implications were of adopting hyperconverged infrastructure by Nutanix. And we found over a reasonable sample of our enterprise customers that they were able to reduce total cost of ownership by over 60%. They had 97% fewer unplanned outages, 3-digit ROI over 5 years, were able to pay back the investments on Nutanix within 7 months, and really be able to contribute to additional streams of revenue within the first year. And you get to do all this while you're partnered with the industry's best support organization. We're spread across 100 countries, have multiple worldwide support centers, and the person who picks up the phone when you have a support case is the one that solves it for you. So all our support engineers are highly trained, have deep experiences and certifications in virtualization and infrastructure technologies, and are in a position to handle a vast variety of issues that you may experience with and outside of your Nutanix environment. And this is what has given us a 90+% NPS score, which is an indicator to whether a customer would recommend Nutanix to his or her friend or colleague. And it is the highest NPS score that we have in the hyperconverged infrastructure space today. So with that, I'd like to thank you for your time, and if you have any questions, please ask away. Thank you.
All right, great presentation by Krish there. Thank you very much. We do have a poll question that's on the screen now, and that is, would you like more information about the Nutanix solution? We've got a lot of good questions coming in. I believe we're going to be able to get back to these via email after the event. I've been answering as many of them as I can as well. So I'm just going to leave this poll question up while I announce our next prize winner. Let's see. We are putting the balls into the chute, shaking the hat. We're actually using random.org to select these winners. And the next winner of another Amazon $500 gift card is David Siegrist. Excuse me if I mispronounce it, Siegrist, David Siegrist of California. Congratulations, David Siegrist of California. You won an Amazon $500 gift card. We have one more gift card to give away still today on the event after our next presentation. So with that, I am going to move on. It's now time to introduce Mr. Matt McPhails, Global Director of Systems Engineering at Scale Computing. Matt, are you with us?
I am, David. Thank you so much for having me.
Thanks for being on the event today, Matt. Take it away.
Absolutely. So, everyone, just to wrap up, I wanted to make sure that we had time to talk about something a little bit different when it came to hyperconvergence, and that's actually efficiency. So what I want to do today is I want to build the case for efficiency, talk about where we've come from and where we're going when it comes to efficiency and hyperconvergence and the edge. So Of course, I would be disingenuous to have an extremely long slide deck with multiple different demos and presentations to talk about efficiency. So this will be a quick deck, and my goal is to be done in 15 minutes or less. So by all means, if you have any questions as I'm going through this, feel free to ask them in the chat bar, and away we go. So where did we begin? How did this all start when it came to virtualization and building out a virtualized environment? It really all started with the SAN. The SAN itself was there in order to be able to house the data, be able to connect everything, to be able to become that central point of the 3-2-1 architecture. And how it was connected, obviously, is you've got JBOD underneath, and you've got a specifically firmware file system running on top. That firmware file system is then connected via a network. That way, anything that needs to connect to the SAN obviously can get to it. All of this is then connected with a management layer. You've got a server that handles the management. You've got specific servers that are then connected there in order to be able to then access the data directly from the SAN. All pretty straightforward. But again, what's the first thing that you do when you have that? You've got a specific object store that is then built as a LUN that is then instantiated out to each of the different servers. All of those servers are doing, again, housing that data in order for you to be able to create virtual machines. And you haven't even gotten to the point where you're installing anything yet. So first things first, after you have that LUN instantiated, you're installing the actual underlying software in order to be able to do anything that is remotely associated with virtualization. And with that, you put a file system on it. So now you got a file system on top of an object store connected across the network, on top of an object store file system, then that's connected via JBOD. So whether that's VMFS, whether that is VHDX, it really doesn't matter. You're still running with multiple different layers here. And then the first thing that happens with that virtual machine that's installed is that you create an object store, VHDK, for example. And then, and only then, are you able to create that VM. That VM, of course, the first thing that happens when you have the VM created is that you've got a file system that's created for the OS just so you can run the application. Now, you guys do this all day long, and you don't probably even think about it. When I was a virtualization admin, I worked at VMware for a number of years prior to coming over to Scale. I didn't even think about this. But the fact is that in order for me to change a period to a comma, my path goes all the way from the application through that first layer of file system, through the object store, through the second layer of file system, through the object store, across the network, through that new object store that's across the firmware layer that then finally connects to the JBOD. 7 steps of hop, latency, and efficiency lost, just for you to be able to change the period of comma. And unfortunately, that doesn't even include the fact that you have to do some sort of mirrored write or some sort of redundancy there in order to make things happen. Thankfully, it's not 2010 anymore. And you guys are on this environment in some form or fashion, but likely you're also moving over, or thankfully you're on this call to think about moving over to a hyperconverged environment because you don't want a complex infrastructure anymore. IT in and of itself is rapidly moving away from that towards edge computing, towards hyperconvergence, towards being able to do things that our friends that you have listened to on previous conversations have already been able to do. But what we're doing even more is that there are smaller, efficient, affordable solutions that are also needed. And what has happened is that the first iteration of hyperconvergence really didn't change that complexity. It just hit it. So when you look at hyperconvergence, when you have to run in a Hyper-V or VMware environment, what all of our peers do is it looks something similar to this. So Now what you're looking at is you've got all of the SAN and the network complexity hidden in a VSA, and for you to be able to, again, change that period to a comma, you're going down through the node hypervisor, across this virtual CPU layer on the VSA, up through the actual local JBOD, through that firmware layer, down through the firmware layer of the VSA, and onto the virtual disk. Now it has to be committed. So you've got to go back through all of those layers again in order for that write to be committed. Now, unfortunately, that write needs to be mirrored. So that has to go through the network, back over through a different node hypervisor, down again through the VSA layer, across that virtual CPU, up through the JBOD, through the virtual firmware of that VSA, and down across the virtual disk. And again, unfortunately, if you're mirroring this for proper storage, you're going to have to make a commit once again, and it has to go through all of these layers. Now, all the friends that you've talked with before now that have been on this call before me, it's not their fault that they have to do this. But the reason why is that in order for this to happen is that they have to put VMware, they have to put Hyper-V, they have to put a hypervisor that they cannot touch because it's closed source in a box. And the efficiency lost by having to put it in a box is huge, as you can see here, because there are 14 different hops for you to be able to change a period to a comma. Instead of, what you could do is build in a layer of efficiency that only includes the hardware and the software that you need. Specifically away from the VSA, which is great for Fortune 500, but it's not efficient for the edge, and it's really not efficient for hyperconvergence in general. What you're looking at is taking all of that complexity, taking out all the pieces that you don't need anymore, the management layer, the servers, any of the extraneous hypervisor, the software itself, and include it all into a layer where the VM talks directly with the storage across the network and mirrors the data easily across a general data store, just like it's direct attached. So now what you're talking about, in order to change a period to a comma, you are actually going one hop across the network, 2 hops, and then you're doing a committed write on another disk on another node. So you're going from this on the left-hand side to that, where, again, they're having to cover up a lot of inefficiencies with caching, with SSDs, with the ability to actually run in a hypervisor that is a closed source system. So you're using anywhere from 12 cores and up to 300 gigs worth of RAM for an entire cluster, to anywhere of a fraction of a core to 12 gigs of RAM for a truly efficient environment that is set up so that you can have all of the VMs talk directly with the hardware. So it's really a case of you get what you pay for. You are trying to maximize the amount of hardware spend that you have and get as much performance out of that hardware spend. That way, you're able to do more with less. Another way to look at it is comparing the left-hand side. This is the amount of writes that you're doing on the left-hand side to the amount of writes that you're doing on the right-hand side. So when you start getting efficient, you start moving away from problems like this. Added complexity, which equals added costs, because you've got multiple vendors, you've got multiple different support contracts. The integration time is tedious. And with that, the expertise that is associated with that tedium is even higher. The scalability issues become apparent. The licensing becomes an issue as well. And quite frankly, if you're talking about DR and backups, now you're having to make decisions on where you want any extra money going to and how to do that the best way. As opposed to our whole idea around this, where if you build it efficiently, you've got a single vendor, you've got no integration time, you've got no infrastructure expertise needed. I actually taught my 4-year-old daughter how to create a VM on the system. The system itself really scales well, and you don't have to worry about licensing, and everything's built in. So it's cool, because now what you're talking about is you've got an efficient solution that rolls into a simple solution as well. So customers start getting interested. So I got a guy in the UK who actually made his setup 10 times faster. He made his maintenance a quarter of the time. His recovery was 10 times faster. And quite frankly, he was able to save over $1 million in his environment because of the fact that he just needed less hardware and less operational costs in order to run the system, which is great. And it really validated what we're doing. And as we continue to do it, because we've been doing this for 10 years, we started getting more. We started getting more validations from some of the trusted advisors. And then from there, we actually started getting awards. And we started getting more industry validation. And we've gotten great validation from the actual tech media as well to be able to do this. All because we wanted to make this efficient and simple as a single pane of glass, anywhere from a edge deployment all the way to a multi-system, multi-cluster management deployment, where you take one of the retail deployments that we have that has thousands of different sites, they can get to it all from a single knock. And all because they wanted efficiency. So why does this matter? Why do you care? It's because you can actually eliminate a lot. You can eliminate the nested files upon file systems upon files upon file systems that I showed you at the beginning. The fact that it's 60% more efficient means you're actually saving 60% of the cost, and you can fully eliminate the need for software and SAN. You're not just virtualizing it away. You're not just using a VSA or controller VM. More importantly, you take your current environment, whether it's hidden this way or it's built out this way, and you just simply move it to something that makes more sense. Only what you need and only as efficient as a direct connection would allow. So with that, I'm at my 15-minute mark. So I want to give some time for questions, but definitely look us up. We've got info on the web, on email, on Twitter. By all means, I really appreciate the time. So, David, I will turn it back to you for any questions that are available.
Yes, Matt, great presentation, very compelling, and also very efficient. So I like that. I'm sure the audience did as well. We do have some questions here for you. So let's see. First one that came in, Phil is asking, what hypervisors do you support?
Great question. Thank you, Phil. So hypervisor is KVM. It's actually built in to the underlying software. So we leverage our own software called HyperCore OS, but it leverages Red Hat's known hypervisor KVM. It's just something you don't have to be an expert in, though. Everything is done through the UI, and in fact, again, you don't need any training on KVM whatsoever.
Very nice. Yeah, I've used scale computing myself, and it is just super easy. So I want to call attention to a poll question on the screen for the audience, and it should say, what additional information would you like about the scale computing solution? So make your selections. I'll just leave that up, and we want to make sure we get you additional information if you'd like it. Another question that came in, Chris is asking, how well or how easy is it to move virtual machines from VMware to scale computing?
Great question. This is something we do every day, because every single instance are you going to get into a situation where, okay, you're going to need to take from an existing environment and move it over to a newer environment. Thankfully, due to the open virtualization format that VMware set out 2008, any VM can run on any other hypervisor. There's really no vendor lock in there. With a quick convert, it is not hard, and we've got tools that enable you to do it. We got tools that enable you to do it with minimal downtime as well.
Nice, nice. Well, that sounds easy. David is asking, how robust are the APIs for Scale's hypervisor?
Great. We actually leverage multiple different APIs depending on what your needs are, and we've got an entire API stack in order for you to be able to use. We love for you guys to be able to have node knobs as you need. Again, we're trying to be a simple solution, but anything from the API is able to run just like anything that you'd be able to do through the UI. So that's our goal there with the API stack. But thank you for that question.
Okay, excellent. Another question, they're asking, what hardware platforms do you work with, or does this run in the cloud?
Great question. So this is an on-prem solution, although we do have partnerships with cloud providers such as Google. We also have multiple different hardware vendors. So we do run versions on Supermicro, but our biggest hardware OEM has been Dell. Has been Dell in the past, but right now it is Lenovo. So Lenovo has been a great partner. They've definitely invested a lot of time and a lot of resources into us, and we're happy with the hardware that they've provided, anywhere from a very small edge style of hardware all the way up to a big beefy node that's available for a very large deployment. We've got other OEMs such as NEC and Fujitsu that we're working with, but all of those just show that we can run on hardware and on just straight software as necessary.
Very nice, yeah. Another question here about Edge. You mentioned Edge. They're asking, is this something that Edge deployments are using today?
Great question. So, as noted in my presentation, the large retail deployment that I talked about, the couple thousand sites, that actually is an Edge deployment. They're leveraging our multi-site management suite. They're actually leveraging this on very small Lenovo boxes, and this is something that they have deployed with specific features that have been catered for Edge-style deployments, such as auditing, such as being able to have multi-user management, and there are other tools in place to be able to really focus on Edge. There's an entire presentation, obviously, out there on Edge that we could review on, but the answer is yes. This works great on Edge because of the efficiency piece.
Okay, nice. Question from Chris. He's asking, what's the minimum number of nodes in a cluster?
Great question. So the minimum number of nodes that we can support are 1, but that's not a cluster. The minimum number of nodes in a cluster are 3, and the reason is because of quorum. You always have to have a tiebreaker. If someone's trying to sell 2 nodes, that really doesn't create a situation where you're getting the most out of your hardware because of quorum and because of having to have an idle node or a node that's only at 50% or less.
Got it. That makes sense, yeah. Do you recommend people do to get started?
So the great thing is that we were always happy to give demos. So reach out to your local partner, reach out to a sales rep if you know who they are, but more importantly, just go to the website. You can sign up for a weekly demo directly off the website. A couple of my guys actually give the weekly demo, and they're more than happy to answer specific questions. We actually make the weekly demo small, so we will not allow more than about 10 people on that demo in order to ensure that you get your questions answered. So feel free to go to the website and just sign up.
Nice. And I've been on those demos before. Actually, it's super easy. That's all I can say about scale computing is everything just seems super easy and efficient, like you said. So I think that's all the time we have for our Q&A section, but it's been really great having you on the event today. Thank you, Matt.
Thank you very much, everyone. Thank you, David.
And thank you to Scale Computing for supporting today's Hyperconvergence EcoCast event. For more information, you can see the Scale Computing data sheet. It's right there in your handouts tab. And the cool thing the scale does is the prices are right on the sheet as well. So you can see all the different clusters as well as the starting price for all those clusters if you'd like more information. So make sure that you check that out. And with that, it is time for our final gift card giveaway. We have another Amazon $500 gift card. That's going to Gershon Blumstein from Michigan. Congratulations, Gershon Blumstein from Michigan. All the winners out there today were Joe Price from Georgia, David Seagrass from California, and Gershon Blumstein from Michigan. Congratulations to the winners. Before you go, I want to remind you to check out the 10 on Tech podcast over in the iTunes store. Also, follow Actual Tech Media on LinkedIn. You can do that by clicking the LinkedIn icon on the top right-hand side of your audience console. And if you are a potential sponsor of an upcoming event, just email us at connect@actualtechmedia.com. And I want to remind you to join us for our biggest event of the year, which is happening next week, surprisingly, next week on November 6th at 12 noon. This is our virtual summit, and the topic is Architecting and Supporting the Pillars of IT in 2020. We will have 13 presentations and an incredible lineup of prizes. So make sure that you join us for that event. In fact, after today's webinar, your web browser should be automatically redirected to events.actualtechmedia.com, where you can register for that event. If not, just open your browser and go to events.actualtechmedia.com. We got a lot of great feedback here, a great presentation, great webcast. Thank you. So thank you to the audience, and thank you to our presenters. I really enjoyed the event. I hope that you did as well, and we will see you next time.